Okay, let's have a look at some exam questions now on the periodic table. Make sure you looked at the modern periodic table lesson and Mendeleev's periodic table lesson, okay, to be able to answer these questions with me. Periodic table. Make sure you look at both of these lessons first before you come and do these questions together. Right, so we've got this question is about the periodic table. Figure 1 shows part of the Mendeleev's version of the periodic table. Which group of elements had not been discovered when Mendeleev's version of the periodic table was published? So if I go back to that lesson, in our modern periodic table, we had the metals, we had the non-metals, and we have these noble gases, right? Fluorine, look at lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So in this case, we've got these lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine, but we don't have those noble gases. Noble gases were not discovered at that time. Right, next one. These are the letters, these letters are not the symbols of these elements. Complete the sentence. All the elements in figure 3, so this is your figure 3, are in group. So from our lesson, we know that group represents the number of outer electrons. So you might need to draw these out. So we've got R, we've got 3 protons and therefore 3 electrons. R would have 2 in the first shell, 1 in the second shell. So the outer electron is 1. I'm going to try another one. So this is the same 3. So it would be also an outer electron of 1. Let's try T. So for the first shell, we've got 2, 1, 2. In the second shell, we can have maximum of 8. 1, 2, 3, 4, 5, 6, 7, 8. So we've got 10 so far. And then on the outer one, we have 1 more to make it 11. So in this case as well, we've got 1 electron on the outer shell. So it should be all in group 1. Next. Okay, this question. Figure 6 shows Mendeleev's periodic table. Explain why the early periodic tables placed iodine before beryllium, and then Mendeleev placed beryllium before iodine. So look at this. We've got beryllium and iodine. This is where we have it. The early periodic table had iodine come first and then beryllium. Whereas now we've got Mendeleev did beryllium before iodine, and they want to know the reason why. So first we've got to answer the first part of the question, which is why the early periodic table placed it in this order. The early periodic table placed it in order of atomic weight. That's right. So early periodic table placed in order of atomic weights and atomic weights only. So since iodine has a lower atomic weight, so it is placed before beryllium. I'm just going to write Te. But Mendeleev came in and look what he did. He reversed that order. And we've seen that keyword before in the lesson. Why would he reverse the order? So that elements with similar properties can be in the same column. We know that iodine reacts in a similar way to bromine, and therefore they have to be in the same column. So Mendeleev reversed the order. So iodine can be in the column with similar properties. Similar properties. This question is about sodium and chlorine. These are the positions. State one difference and similarities between the electronic structure. Keyword there that represents just talk about the electron, outer electrons, electron shells, sort of things, of sodium and chlorine. So sodium and chlorine are in the same row number, so period. What is period? The number of electron shells. So similarity, they've got the same number of electron shells. And how many we can write shells? 1, 2, 3. They both got 3 electron shells. However, the group number, this is number 1, this is number 7, are different. So when you write a difference, make sure you give both sentences. You would say sodium has 1 outer electron, but chlorine has 7 outer electrons. Right, next question. This question about elements in periodic table, what order did scientists use to arrange elements in the early periodic table? Right, so not the modern one, the early one. And we have to call that the atomic weight. Yeah. In the early periodic tables, some elements were placed in the wrong groups. Mendeleev overcame this in his periodic table. How did he do that? In the early periodic table, some elements were placed in the wrong groups. Mendeleev overcame this in his periodic table. He left gaps. So he didn't force it to belong into a group, right? He left gaps for undiscovered elements. And by leaving gaps, you're not placing them in the wrong groups. You're placing them in the correct ones. So that's 1 mark. Explain why neon is unreactive. Electronic structure. Remember, that's to do with the electrons. So neon has a full outer shell. So it is stable. Right? Next question. Well, how do I know neon is has a full outer shell? In the periodic table, neon is in group 0. Group 0 represents all of these have a full outer shell. June 2019. This question is about the periodic table. In the 19th century, some scientists tried to classify the elements by arranging them in order of atomic weights. Figure 1 shows periodic table Mendeleev produced in 1869. His periodic table was widely accepted than previous versions. So question 1.1, the atomic weight of beryllium is 128 and iodine is 127. So we saw this exact question come up just a few minutes ago, right? Why did Mendeleev reverse the order so that elements with similar properties can be in the same column? Right? Mendeleev left gaps. Why did he leave the gaps? Undiscovered elements. So he left these spaces because he thought missing elements belonged there. Why did Mendeleev's periodic table become more widely accepted than previous versions? And we've seen this keyword in our lesson, right? The scientist accepts the model because after a few years, when the elements were discovered, they fitted the gap and they matched his predictions, right? So that's what we have to write down for an answer here. So Mendeleev predicted the properties of the undiscovered elements. That will give you 1 mark. The discovered elements fitted the gap and matched his, so that will give you another mark, and matched his predictions. That will give us the third mark. Right? Mendeleev arranged the elements in order of atomic weights. What's the modern name for atomic weights? We had a look at this in our lesson as well. Atomic weight is the relative atomic mass. In the modern periodic table, what are the elements arranged in? In the modern periodic table, we know that it's arranged in order of atomic number. So that would be atomic number. June 2020, Mendeleev published his periodic table in 1869. Mendeleev arranged the elements in order of atomic weights. Mendeleev then reversed the order of some pairs of elements. Remember, why? So that elements can be in the same column. A student suggested Mendeleev's reason for reversing the order was to arrange the elements in order of atomic number. What is atomic number? The number of protons. And they're telling us, the students telling us, Mendeleev chose to reverse them so that it's in order of protons. But what did we learn about protons and Mendeleev? Protons and Mendeleev, protons, they were not even discovered at that time. So can she be correct? Or can he be correct? Can they be correct? No. Because atomic number is the number of protons, which were not even discovered, which were only discovered later, right? Or they were not discovered at that time. So they cannot be correct. Give the correct reason. It's the same sentence, guys. So that, you should know this by now, elements with similar properties can be in the same column. Look how repetitive this question is. Mendeleev published his periodic table 1869. Oh, we just did this. Right, next one. Gallium was discovered 6 years after Mendeleev published his periodic table. So this was discovered. This is a discovered element, they tell us. And give 2 reasons why discovery helped Mendeleev's periodic table to be accepted. We've seen that keyword again, accept. So what do we know? The discovered element fitted the gap. And that the discovered element matched his properties, predictions. Discovered elements matched his predictions. Right, we got one last question. We've got sodium and potassium are in group 1. Electronic structure, remember, that's talking about electrons. Very, very repetitive, yeah? Give one similarity. Group 1 means they have the same number of outer electrons. And now let's compare sodium and potassium on the periodic table. So look back at your periodic table. Sodium is in period 3, potassium is in period 4. So you would say sodium, sodium has 3 electron shells, but potassium has 4 electron shells. Hopefully you understand this topic really well now. Thank you.